there's a well-known star you've probably noticed shining in the night sky. It's called Betelgeuse, sitting in the Orion constellation and marking Orion's right shoulder. Yet something unusual has been happening with this star lately. This red supergiant has been dimming on and off throughout the past few years, which may suggest that it's nearing the point of going supernova. Betelgeuse is roughly 600 light-years distant from Earth, meaning the light reaching us today left the star around 600 years ago. Interestingly, its precise distance is still uncertain, though that estimate is close. If Betelgeuse had already blown up in a supernova within the past 600 years, the explosion's light would still be on its way toward our planet. In short, it's entirely possible that Betelgeuse already exploded long ago, and we might witness the event at any moment, even as soon as tomorrow. When Betelgeuse finally becomes a supernova, it will be the brightest one ever witnessed by humans. So, just how bright could it get? Could it be seen during daylight? Would it pose any threats? And why do recent findings about Betelgeuse challenge our present knowledge of stellar physics? Welcome to territory. This is your space. The core of most stars, including Betelgeuse, is composed of hydrogen and helium, the lightest elements in the cosmos. Once the core exhausts its supply of nuclear fuel, it can no longer support the star's outer layers, resulting in a gravitational collapse. As the star caves in under its own mass, it heats and compresses until internal pressure grows far too intense. This rapid inward plunge produces a shock wave that blasts off the star's outer layers in a colossal eruption. The outcome is a supernova that unleashes an immense surge of light and energy, sometimes outshining entire galaxies for a brief moment. To put this into perspective, our sun has a luminosity or power output of 3.8 1026 watts. Yet a supernova recorded in 2015, known as Assassin 15LH, achieved a peak luminosity near 21038 watts. That brightness equals the combined output of more than 500 billion suns. But why didn't we see it from Earth, you wonder? Because Assassin 15LH occurred in another galaxy. Betelgeuse, by contrast, resides in our cosmic neighborhood. This closeness means Betelgeuse's supernova would appear incredibly bright, possibly outshining even Sirius, the brightest star visible at night, and would likely remain visible for weeks. But will it present any danger to Earth? A supernova exploding within several dozen light-years of our planet would carry severe risks, including harmful radiation exposure. The hazard zone for these effects is estimated at roughly 100 light-years. Fortunately, Betelgeuse is well beyond that threshold, so we're safe. For comparison, if Alpha Centauri, a nearby system just over 4 light-years away, went supernova, it would glow as brightly as the moon and bathe Earth in damaging radiation. But Alpha Centauri is not massive enough to become a supernova. While other visible red giants might one day explode in such a manner, Betelgeuse remains the most intriguing candidate. And that's why its recent behavior has captured scientists' attention. One remarkable feature of Betelgeuse is its rotation. Recent readings from the ALMA telescope array revealed that Betelgeuse spins at a surprisingly fast rate for a star of its immense size, roughly once every 20 years. This means its surface rotates at around 18,000 km or 5 km, far quicker than Earth's rotation. Such rapid rotation is unusual for a star this massive and challenges our assumptions about stellar physics. But how do you measure the spin of an object so distant? Through the Doppler effect. Picture an ambulance siren blaring as it approaches. As it nears you, the pitch sounds higher because the sound waves are compressed. Once it passes and moves away, the waves stretch out, making the pitch drop. This shift in pitch due to motion is called the Doppler shift. Likewise, for Betelgeuse, one half of the star's surface moves slightly toward us, while the opposite side moves away, creating a gradient of color shifts. By analyzing these shifts, astronomers can calculate the star's rotation rate. For Betelgeuse, that rate turned out far higher than expected, and now scientists understand why. In recent years, several studies proposed that a small, close binary companion might explain Betelgeuse's periodic dimming. This is where the challenge begins. Betelgeuse is so enormous and bright that detecting a smaller, dimmer neighbor right beside it is extremely difficult. That's when Steve Howell, a scientist at NASA's Research Center, and a team of astrophysicists decided to bring in a game-changer a la Peak, a speckle imager mounted on the Gemini North Telescope, to finally solve the mystery. What makes it special is its speckle imaging ability, a technique using extremely short exposures to freeze the distortions created by Earth's atmosphere. This approach enables sharp resolution, which, combined with the Gemini North Telescope's 8.1-meter mirror, allowed Betelgeuse's faint companion to be directly identified for the first time. The glowing orange sphere is Betelgeuse, and the faint blue streak beside it is its newly discovered companion. Betelgeuse, whose name means "hand of the giant" in Arabic, now officially has a stellar partner that astronomers have proposed naming Saorha, meaning or bracelet. Personally, I can't think of a fittinger name for the star orbiting Betelgeuse. After the discovery, Howell and his team studied the companion's light to pinpoint its characteristics, and what they uncovered matched earlier predictions for Betelgeuse. The research papers were published in the Astrophysical Journal Letters and are linked in the description below. They determined that the companion star is 6 magnitudes dimmer than Betelgeuse in the optical range. It has an estimated mass of about 1.5 times the Sun's and is a hot blue-white star orbiting the red giant at a distance equal to 4 times the Earth-Sun separation. Quite close for a binary system. That means it resides inside Betelgeuse's extended outer atmosphere. The team also believes this star has not yet begun burning hydrogen in its core, the process marking a star's main sequence stage. Consequently, the Betelgeuse system now includes 2 stars sitting at opposite ends of their life cycles, even though they formed together. This delay doesn't ensure that Betelgeuse's companion faces a long future. We're confident that Betelgeuse will ultimately erupt in a cataclysmic supernova, although the exact timing is unknown. Even though Betelgeuse is only about 10 million years old, its immense size, roughly 700 times that of our Sun, means it has burned through most of its fuel far faster than our 4.6 billion-year-old star. In this situation, the companion star confronts 2 bleak possibilities, neither encouraging. First, Betelgeuse's immense gravity could draw the smaller star inward, consuming it in a cannibalistic event that may happen within the next 10,000 years. Alternatively, Betelgeuse could explode before fully engulfing its partner. Such an explosion could disrupt the companion's orbit, potentially hastening its end or sending it onto a different trajectory entirely. So yes, neither scenario bodes well for the companion. But for now, astronomers will continue searching for more answers. In November 2027, we will gain another view of the companion when it reaches its greatest separation from Betelgeuse. Rest assured, uncovering this smaller, dimmer star is truly extraordinary. What do you think? Share your